okay? So rational function is a pretty short topic, okay? So hopefully we can finish this today, okay? And then next week, we can start on our last chapter, okay? Sequence series, which is not too bad, okay? We got through the hard stuff already. Okay, so rational function, rational means anything that can be written as fraction, right? So you can see that here we have all the function has a fraction look, right? So like these ones, right? They all have fractions. So here in this topic, we'll be learning how to graph them, okay? And I grouped them into 4 different types, okay? So, and the types, it depends on the degree of the numerator and denominator, okay? Depending on numerator and denominator degree, we have different ways to draw them, okay? So type 1, okay? Type 1 is as n less than d. So n is for numerator degree, okay? And d is the denominator degree, all right? And then the second type is when the degrees are the same, okay? First type is numerator is smaller, okay? And then next one, third type is when the numerator is bigger, right? And then so that covers all the different types. But then the type 4 is the one that could happen in either type 1, 2, or 3. Okay, so type 4 is talking about a graph that has a point of discontinuity. But this could happen in any of the 3 types. Okay, so you could put a little star on type 5. Okay, and you can say could combine with type 1, 2, or 3. Okay, so that means type 1, you could also have POD, okay, point of discontinuity, POD, right, or type 2 or type 3. All right, any questions? So that's a general rule, okay? So today we're just gonna cover these 4 types, right? So type 1, okay? So first thing, when you get a question, of course, they won't tell you which type it is, okay? I grouped them for you, right? So you can learn one by one. So when you get a question, first thing is to check their degree, okay? So degree is to look at the exponent of the variable, okay? The highest one, then you call that the degree. So for the top, numerator, right? Because there's no variable at all. So the degree is 0. So you just write n equal to 0, okay? And for the denominator here, the one that has the variable is only x, right? And x has to the power of 1. So we have denominator degree equals to 1. Right? So here you can see n is smaller than d, right? 0 smaller than 1. So that's why it belongs to type 1. So first thing we want to do is to find out the asymptote lines. Okay, so you probably have heard of asymptote in grade 11, right? So, and also in the exponential, right? Exponential and log, we also have asymptote. So we have 2 kinds of asymptote. One is the vertical asymptote, okay? Vertical asymptote is you look at the denominator, okay? So when denominator equals to 0. Okay, so the denominator here is x minus 2. So you put x minus 2 equal to 0. And solve for x. So x equal to 2. So that will be the equation of the vertical asymptote. So what does it say? Telling you is when x equal to 2, there is no point to graph. Right? If you sub in x equal to 2, right, denominator will be 0, and that's undefined, right? So x equal to 2 is the location where there's no graph at all. okay, empty space. All right, next part is called the horizontal asymptote, right? We have two kinds of asymptote. So horizontal asymptote, if it's n less than d, right? N less than d, you can write that down, n less than d, then the horizontal asymptote is always y equal to 0. Okay, you can memorize it as a rule. Okay, when n less than d, then it's always y equal to 0. And later when we start graphing, then I'll explain why this happens. Okay, why is it y equal to 0? Okay, number 2. Okay, second thing we want to figure out is the domain range. Okay, just like when you do the polynomial, right? You want to write out the domain range, the polynomial functions. So for rational, right, it's you look at the vertical asymptote and horizontal asymptote. So that's it will tell you the domain range. Okay, domain is about the x. So x here, it can never be 2, right? It will make the denominator 0, right? So you just say x cannot equal to 2. Sometimes your teacher will also want you to write x as real number, right, together. So that's okay, right? So what that is saying is x can be anything except 2, okay? And then for range is about y, right? So in this case, because horizontal asymptote is 0, so you would say y cannot be 0, and y can be anything else. Okay, any questions so far? Okay, so far we got domain and range. Okay, so that's your answer for part 2. Okay, we have 4 things to find, but then number 4, we save it for type 4. Okay, so number 3, we need to find the x-intercept and y-intercept. Okay, how do we find x-intercept? Cindy?
Set y as 0.
Yeah, very good. Okay, so we will have 1 over x minus 2. We set it equal to 0. Okay, so if I want to solve for x, what should we do now? Eric?
Divide both sides here by x minus 2, or multiply both sides by x minus 2.
Yeah, you would do the multiplying, right? Because x minus 2 is in the denominator, right? It's divided by x minus 2. So you got to do opposite. Or, okay, so let's say if we do that, then the left side, if I multiply by x minus 2 on both sides, what will happen on the left side now? Donna? If both sides times x minus 2.
The left side would be 1.
Left side will be 1. Right? Left side will be 1. What about the right side?
0.
0, yeah, okay. Anything times 0 will be 0, right? When you times the left side, x minus 2 will cancel out, so you get 1. So as you can see now, there's no more x, right? And then you see 1 equal to 0. Does 1 equal to 0? It doesn't, right? So that means there's no x value that can make it equal to 0, okay? So this one, it has no x-intercept. Okay, so for this one, when this happens, another way to think about this one is if you want to have a fraction, right? You want to make it equal to 0, then you must make sure the numerator has to be 0, right? The top has to be 0. And the denominator cannot be 0 because it will be undefined, right? So you just need to worry about the numerator. But then in this case, the numerator is a 1, right? So that's why it's no way it's ever going to be 0, okay? So you don't even need to do multiplying at all, right? Just looking at the fraction, the top is a number, right? Has no variable, so it's impossible to equal to 0. Okay, next one is the y-intercept. Okay, y-intercept, we just sub in x equal to 0, right? So it'll be f of 0. So it'll be 1 over 0 minus 2. So 1 over -2. Okay, so this one we have a y-intercept. Okay, any questions so far? So for each of the rational function, we can get these 3 things first before the graphing, okay? Now, when we draw the graph, we need a table of value, but then we want to choose the table so the points are important, right? So the most important place is the vertical asymptote, okay? Vertical asymptote is at 2. So I'm going to put the 2 in the middle, okay? Because that's the vertical asymptote. And then at 2, when x equal to 2, there's no value, right? It's empty. So we'll put undefined, right? 0 with a slash across, that means it's empty, okay? There's no y values. And then all you need to do is just start graphing near the 2, okay? So you can say I want to graph 3, right? Graph 4. Okay, let's do, okay, since this one is our first question, we'll do closer points, okay? We'll do 2.5, and then 3, okay, and then 4. Okay, and then on the left side, we'll do 1.5, right? Smaller than 2, and then 1. Okay, so these x value are going into the function, right? So you guys can take out your calculator, okay, and punch in these inputs. And when you fill out the table, okay, please raise your hand, okay? I'll ask for your values. So for example, if I sub in 1, right? 1 over 1 minus 2, so that's -1, okay? All right, so you guys continue, finish the table and raise your hand. Okay, Donna, what do you get for 1.5?
-2.
-2, thank you. And Tiana, 2.5?
2.
2, okay. Cindy, how about 3?
1.
1, okay. Eric, 4?
Half.
Half, okay.
Yes.
Right, so now let's plot it in, okay. Is it half? Yeah, okay. So just follow the table, right? And because the points are not too big, right? So I'm going to just draw 1, 2, 3, 4 for x. Okay. Same with the other one. 1, 2, 3, 4. And before you draw the points, okay, let's draw the asymptote too, okay? Vertical and horizontal asymptote. And you can grab a different color pen, okay, so it's clearer. So we have x equal to 2, right? This is x equal to 2. So x-axis stays at 2, so it's a vertical line. Every point on this vertical line has x value of 2, right? So that's why it's called x equal to 2. And then y equal to 0, then that will be the x-axis, okay? So use a different color so you can see better, right? It's on top of the axis. So you have x equal to 2 here and y equal to 0. Okay, so those are the places that you cannot have points, okay? Now let's see, plot the points now. 1, -1, so that will be here. And then 1.5, -2, so it'll be down here. And then the other side, 2.5 is 2, 3 is 1, 4 is half. Okay, so as you can see that if it's closer to 2, it will start to bend, right? That's why I chose the 2.5 and 1.5. Right? 1.5 is -2, right? The closer it gets to 2, it will go down lower, right? So it will go down this way, right? If you have a bigger table, right, you can draw more points. And then if I go to the left, right, we also have y-intercept, right? Y-intercept is a -1/2. So that means is up here, y-intercept, right? So you can see that the more to the left, it will go up higher, but then it will not touch the horizontal asymptote, okay? So the graph will bend this way. And then same thing, right? As you can see from the table, right? If the x value gets bigger, that means you are dividing 1 by a bigger number, right? Because the function is 1 divided by x minus 2, right? So x gets bigger, that means denominator gets bigger, right? But then the overall value will get smaller. So the more to the right, it gets smaller, right? So the graph will bend this way. So the reason why you have horizontal asymptote of y equal to 0 for type 1 is if x gets bigger, right? You just imagine if x gets bigger and bigger, then eventually the whole answer will be close to 0, right? So that's why we say y equal to 0 is your horizontal asymptote, okay? So to find horizontal asymptote, you can make a note here. Okay, the general rule for getting horizontal asymptote is to see what happens. Okay, what happens to y when x gets to infinity. Okay, when x gets really big, and then the number it gets close to, then that's your horizontal asymptote, right? So in this case, if x gets really big, your whole y value gets to close to 0. So that's why it's y equal to 0. Okay, so that's our first type, our first example of a rational function. Okay, so the second question at the bottom is similar. Okay, you go through the same 1, 2, 3 and make a table. Okay, how about I let you finish 1, 2, 3 first? Okay, and I'll check that and then we'll do the tables together, right? So when you finish 1, 2, 3, you can raise your hand. first thing you double check your n, okay, and find a d. Okay, make sure it's type 1, right? If you get stuck on anything, you can just do whatever that you know first, okay? And then when you go through everything, okay, 1, 2, 3, even if you didn't get anything, you can raise your hand, okay? So I know you've tried it. Okay, how many of you have finished number 1? Can you raise your hand? Okay, okay, good. Keep going. When you finish 3, you can raise your hand again. All right, we are almost all done. Okay, let's check the vertical asymptote first. Cindy, what's the vertical asymptote you have?
2 and -1.
X equal to 2 and -1. Okay, how about Eric? Do you have the same?
Yeah.
Okay, can you tell us?
Yeah.
You have different?
No, I have the same.
Okay, can you tell us how did you do it?
I factored it to x plus 1, x minus 2.
Okay, very good. X plus 1, x minus 2. Right, the denominator equal to 0, right? This is a quadratic equation. Very good. How about horizontal asymptote? Tiana?
0.
Yep, y equal to 0. Okay, so make sure when you do the homework, when they ask you to write the asymptote, you have to write the variable, okay? Because that's very important. X equal to 0, y equal to 0 is completely different, right? So make sure you also write down the variables, okay? Next one, the domain. Okay, domain is basically just saying the opposite of the vertical and horizontal, right? So here I'll write it out. Can I equal to 2 or -1? But it can be everything else, right? Cannot be 0, but y can be anything else. Okay, x-intercept. Donna, what's your x-intercept?
No x-intercept.
Yep, so this one, none. Very good. And Samantha, do you have the y-intercept? Yes or no? No? Okay. How about Tiana?
Y equals to -1.
Okay, can you tell us how you found it?
You input 0 in the x's.
Yeah, very good. Okay, so f of 0 and then 2 over, so all the x will become 0, right? So 0 minus 0 minus 2. So end up at -1. So y-intercept is at -1, okay? And there's no x-intercept. Now the thing that's very different is this time we have two vertical asymptotes, right? So when we make the table, right? Remember when we did the table before, we place the vertical asymptote in the middle, right? Look at the highlighted, and then we graph a little bit on the left side and then a little bit on the right side, right? So we need to know what's happening around the asymptote. So when we make the table for this graph, right, the second graph, you want to make sure you also have points around both asymptotes. So we need to space out our table, okay? You need at least 1 point on each side. So here I'm going to put, right, because -1 and 2 is not too far apart, right? -1 and then to the right will be 0, right? And then 1 and then 2, right? So we can fit them all in, right? So we'll do -1 here, right? -1. So you have a space on the left, right? And then 2 here. Okay, so those are the places you get undefined. Okay, and then we just graph around it, right? So on the left side of -1, so Cindy, what's the number on the left side? Cindy, are you there?
Yeah.
Yeah, did you hear my question?
Yeah.
Okay, what's the number?
Uh, 0.
Left side. Left side of -1.
-2.
Okay, right side?
0.
Yes, okay. And then the next one for the 2 will be 1, right? On the left side, right side will be 3, okay? So you just need to have at least 1 point on each side of the asymptote, okay? I don't think you will get 3 asymptote, okay? For grade 12, the maximum asymptote for vertical is just 2. Okay, so please find the values again by yourself. And then I'll let you also try the graph, okay, by yourself as well, all right? So when you finish the table and also the graph, you can raise your hand. Okay, actually raise your hand when you finish the table, okay? I want to make sure the values are correct. And if you are sure that your values are good, you can continue on the graph, okay? But please raise your hand when you finish the table. Okay, let's compare the values. Okay, Donna, what do you have for -2?
Half.
Half, okay. And for 0, Eric?
-1.
Yeah, okay, so that's the y-intercept, right? Tiana, how about 1?
-1.
-1 as well, okay. And Cindy, for 3?
0.5.
0.5, so also half. All right, so you guys can try to draw the graph. And if you finish the graph, you can raise your hand again. start by making the scales first, okay? After you got the scales, draw all the asymptotes and then place the points, okay? Right, so we have one asymptote here. The other one's at 2. Right, and then we have, don't forget the horizontal, right? Horizontal is y equal to 0. Okay, and then now put the points in. -2 is half. So half will be here. 0 is -1, your y-intercept. 1 is also -1. 3 is half. Okay, so you can start drawing the curve. Raise your hand when you finish. Does anyone have trouble? We just have 4 dots. So how are we going to make the curve? Any question, Cindy? Yeah. Okay, so let's see. Tiana, are you able to draw on the screen?
Yeah.
Okay. And try to show us your graph. Okay, pretty good. Yeah, yeah, very good. Okay, so basically the points just show you the location of the curve, right? Because the asymptote divides the whole grid into 6 parts, right? So you need to know where, in which part it has the graph. And then after you know the location, then you just bend the curve so it gets closer and closer to the asymptote line, okay? Then you'll be fine. So for the left one, right, top left corner, it bends like that, right? And then for the right side, right, it gets closer and closer to both asymptotes, okay? The more tricky one is the one in the middle, okay? to the left side, it will go down, right? And then to the right side, it will also go down, okay? So it doesn't go up. And if you want to confirm that, right, what you could do is you make more points. For example, in between 1 and 2, you can sub in 1.5, okay? And then you should be able to see that the point, it gets lower, okay? Lower than -1, right? And then you can also put another point between 0 and -1, right? Let's say -0.5, and then you sub it in, right? Then you will see it also gets lower, okay? So basically you just get 1 point on each side and then just follow the asymptote lines. All right, so that will be your type 1, okay? Type 1 is n less than d, okay? N less than d, horizontal asymptote is always y equal to 0, right? So different types will have different rules for horizontal asymptote, okay? So let's move on to type 2. Type 2, we make the degree bigger now, okay? So this time, type 2, numerator equals to denominator degree. So same thing, we'll start by checking the degree, all right? So for the numerator part, what's the degree for numerator, Cindy?
1.
Yeah, very good. Okay, so we have x to the 1, right? So same thing with denominator, right? D is also equal to 1. So that's why it belongs to type 2. So when they are the same, vertical asymptote is still the same way to find it, okay? You need to make the denominator be equal to 0. So what is the vertical asymptote? Donna?
-1.
You have to say the variable too.
X equals -1.
Yes, very good. Okay, so x plus 1 equal to 0, x equal -1. So that's our vertical asymptote. Okay, the new thing is a horizontal asymptote. Horizontal asymptote when degrees are the same. Okay, remember I told you that the general rule is to see what happens to y, right? What happens to y values if I make x bigger and bigger, right? The general rule. So let's see what happens, okay? We'll look at the right side. Okay, so if x gets bigger and bigger, okay, so let's say if x is 1,000, okay, I would like you guys to try, take out your calculator, sub in x equal 1,000 into the function, okay? When you got the answer, please raise your hand. So let's put it on the side, okay? So let's say I use the green, right? X is 1,000, right? F of 1,000. Okay, let's see what happens. Okay, so Samantha, what do you have? F of 1,000.
2,999 over 1,001.
Yeah, and what's the answer when you divide them?
2.996.
Yeah, 2.996. So that number is really close to 3, right? Almost 3. So if I try to sub in an even bigger, it will be even closer to 3. So we will say the horizontal asymptote for this, it will be y equal to 3. Okay. So you can do it by this way, by stopping a very big number, right? Or you could also use the rule, okay? For type 2, to find the horizontal asymptote, it will be y equals to, okay, you can write down this rule, okay? If you don't like to sub in values, right, you could just follow the rule. Let me erase this one. Okay, so y equals to quotient. Quotient means dividing, right? Quotient of um, coefficients of the leading term. Okay, leading terms means it's the highest degree term. Okay, just like when we learn the polynomial, right? You have to look at the leading term, right? Whether it's even positive, even negative, right? Remember, right? You have to look at the highest degree one. So in this case, you are looking at the coefficients, right? Coefficients of the leading term. So in this case, the coefficient for the numerator is 3, right? The leading term. And for the denominator, it will be 1. Okay, so if you divide 3 by 1, right, that's how you get the 3. Okay, so for this example, it will be y equals to, okay, let me rewrite this. Okay, so it'll be y equals to 3 over 1, which is the 3. Okay, so that's another way to figure out the 3 without subbing in a big number. Okay, but either way works. Okay, if you like memorizing the rules, then you do it dividing with a coefficient, right? So recap quickly, right? Type 1, for type 1, horizontal asymptote is always y equal to 0. For type 2, it will be quotient of coefficient. Okay, now let's go to number 2 now. Okay, so number 2 will be easy. Okay, everything after number 1 is pretty easy. Number 2 is the domain range. So domain, you just say x cannot be -1, right? And it can be anything else. And then range, same thing. Y cannot be 3, and y can be everything else. All right. And then third one, I'll let you try this by yourself, okay? X-intercept and y-intercept, okay? This time we will have x-intercept and y-intercept. So please raise your hand when you have found both intercepts. X-intercept, you have to make the fraction, right, equal to 0, right? Y has to be 0. But you would focus on the numerator, okay? And for y-intercept, it's f of 0. Okay, so what is the x-intercept that you have, Eric?
1/3.
Yep, very good. Okay, so 3x minus y equal to 0 gives you x equal to 1/3. And y-intercept, Tiana?
-1.
Yep, very good, -1. All right, so we got everything that we need. And then the way to do the graph is the same, okay? So this time, I will let you complete both tables and the graph, okay? So start with the asymptotes, right? This one we have vertical asymptote, only one of them, right? So you put that in the middle and you can choose a couple points on each side, okay? But then in fact, in your homework, you could just draw 1 point on each side, it's fine, okay? If you want to get more accurate, you put more points. So I'll let you finish that. When you finish both table and the graph, you can raise your hand, okay? And we'll check both together. Okay, let me get one of your table, okay? Cindy, what points did you use for the table?
-3, -2, -1, 0, 1, 2.
Okay, can you tell us your y values then?
5, 7, skip that, and then -1, 1, and 1, and 1/3.
Sorry, -1.
-1, 1, and then 1 and 1/3.
1 and 1/3. Okay. Okay, thank you. Anyone disagree that has different values? You can let me know, okay, and then we can check. So vertical asymptote in the middle. Okay, draw the asymptotes first. So looks like it's going up higher, right? 1, 2, 3, 4, 5. Our extenders. 6, 7. Okay, so double check your table with Cindy's table here. If you have something different, you can let us know. So -3, I'll draw the asymptote first. Okay, -1, x equal to -1, y equal to 3. So this time is higher, right? Please raise your hand if you finish the graph. And then -3 is 5. Will be here. 1, 2, 3. -2 is 7. 0, -1. 1, 1. 2 is 1 and 1/3. So 1 and 1/3. So here, right? And then we also have intercepts, right? Make sure you also have that. X-intercept is at 1/3. So that will be like here. Y-intercept is at -1, right? So you can see the points are curving, right? Okay. Cindy, Samantha, any questions about the graph? Have you finished? Okay, so Donna, can you draw on the screen?
Yeah.
Yep. Yep, very good. Okay, nice drawing, right? So pretty easy, right? Easier than trigonometry, right? So you just follow the points, follow the rules for horizontal asymptote, then you'll be fine, okay, in this chapter. Okay, so we have our type 2. So before we head for a break, I want you to do one more, okay? So next one down here. Okay, so let's start. Number 1, right? First we check the degree, right? N equal to, D equal to, okay? So Tiana, what's the N and D?
2 and 2.
Yep. So this time they are different, right? Higher, but still they are the same. So it belongs to type 2. So VA and HA. And then domain and range. Okay, and then we have x-intercept, y-intercept. So we'll check 1, 2, 3 first. All right, so if you finish 1, 2, 3, you can raise your hand. For horizontal asymptote, you can do whatever way you like, okay? You either follow the rules or you could subbing a big number, right? Subbing 1,000.
Jason,
Yeah, Donna.
what part do you like usually pick for horizontal?
Horizontal asymptote?
Yeah.
What do you mean, what part?
Do you use the rule or
Oh,
plug in?
for me?
Yeah.
Okay, for me, I use the rule faster,
Okay.
right? So yeah, but then the subbing in is to help you understand why we have that rule.
Okay.
Okay, but on the test, on the homework, it will be faster. You just use the rule.
Okay.
Okay. All right, let's check the vertical asymptote. Okay, Cindy, what do you have for vertical asymptote?
-2.
-2. Anything else? Just -2.
Yeah.
Okay. Anyone got more for vertical asymptote?
Oh wait,
And 0. How do you get the 0?
'cause X is on the side. I took it out.
Yeah, take it out. Very good. Okay. So you need to factor the denominator, right? Make it equal to 0. So you could either have -2 or 0. Okay. Now horizontal asymptote, if we follow the rule, right? You just look at the 1 and 1, right? The coefficient. So the horizontal asymptote is y equal to 1, right? So it's much faster if you use the rule. If you use the subbing at 1,000, you will need a calculator to do that, right? So next one, domain. Domain range is just the opposite. So x cannot equal to -2 or 0. X is real number. Y cannot be 1. Y is real number. Okay, x-intercept. Eric, what's your x-intercept?
4 and -1.
X equal to 4 and -1. And how did you get that?
I did x squared minus 3x minus 4 over x squared plus 2x equals 0.
And then?
Multiply both sides by x squared plus 2x.
Yeah.
And then factor for
So what's the factor look like?
x minus 4 times x plus 1.
Okay, x plus 1. So you could just focus on the numerator, right? Next time you could simplify your work. Just take the numerator and make it equal to 0. All right, and then y-intercept. Donna, what do you have for y-intercept?
I got none
None. Okay, how come?
because I plugged in 0.
Yeah,
into-
and what happens?
I got -4 over 0 and then it's undefined.
Yes, okay, so x, if you sub in x equal to 0, if you remember your vertical asymptote, you have 0 as well, right? Also in your domain, you just wrote it down, x cannot be 0. So that's why if you try to sub in 0, it shouldn't work, right? You get undefined. All right, so we got everything we need, right? No y-intercept, we have 2 x-intercepts, okay? And we have seen graph that has 2 vertical asymptote, right? So I'll let you try to do the table. Some points on the left, right? Points on each side of the vertical asymptote. So I will have -2. I'll put 0 here, okay? So choose points beside each asymptote. All right? So I'll let you complete the table. So raise your hand when you finish the table, okay? I think this one is a little bit different when we graph, when we start to graph, okay? So that's why I want you to check the table first. So even though we have 2 vertical asymptote, it doesn't mean it will always look like the previous page, okay? So we'll see. So it's always safer, right, to have a table of values. So please raise your hand if you finish the table. Okay, are you guys finished the table yet? I think this one is a bit difficult. It takes a bit longer, right, to plug it in. You have square inside, but you can use calculator, right? And make sure when you type into calculator, you need to have brackets, okay, around the numerator and brackets around the denominator. Does anyone have questions, trouble with getting a table? Okay, let's check one of the points, okay? Eric, what's your first point that you chose?
-3.
-3, okay? And what did you get for that, -3?
4, 2/3.
4 and 2/3, okay.
Yeah.
Okay, and Cindy, do you have a point on the right side of -2?
I chose -1.
Okay, and what did you get for that?
0.
0, okay. So -1, 0. Oh, so that's the x-intercept, right? All right, and then we need another point between -1 and 0. Donna, did you choose anything between that?
Oh, I chose like a different one.
What did you choose?
Like I chose -1.5.
-1.5. Oh, okay. Okay, let me fill that in, right? I'll put it, so -1.5 will be between -1 and -2, right? So -1.5.
Yeah.
And what's your y value?
Um, I'm not sure. I think it's -3.6.
Okay. You use the calculator, right?
Yeah.
Okay. Hold on. My screen just shut off. Okay, I need to restart my sharing. Okay. You guys can keep going, right? So when you finish the table, raise your hand. I think the computer needs a break too, huh?
Wait, I'm gonna change it to -0.5.
Oh, you want to use -0.5 instead? Okay. That's okay.
Yeah.
I can keep your points. It's fine. And you can add in the -0.5. It's taking really long to load the document. Look at how much we've learned, right? So many stuff. Can't believe it's still loading. Okay, I think we got it. So negative 1.5 is negative 3. Okay, so Tiana, did you use negative 0.5?
Yeah.
Okay, what's your answer for that?
Negative 3.6.
3
Oh,
point.
negative 0.5. I didn't use negative 0.5. I
Oh,
used negative 1.5.
okay, so that one you got negative 3.6.
Yeah.
Okay, so Donna, did you get exactly negative 3 or negative 3 point something?
No, you heard it wrong.
Huh? What do you mean?
You heard it wrong.
No,
I said negative 3.6.
oh, okay, 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 negative 3.6. Yeah, anybody use negative 0.5? Does anyone use negative 0.5?
I used it.
Okay, Eric, what do you have?
I got 3.
3, okay. So
Whoa.
let's add that in, okay? All right, now one more point, okay? On the right side of 0, Cindy, what did you choose?
0.5.
0.5, okay. So what do you have then?
Negative 4.2.
Negative 4.2, okay. Anyone want to add another one on the right side?
1
Yeah,
and negative 2.
negative 2, okay. Yeah, because this one is a little bit special, okay? So the more points we get, the better, okay? And later I will explain how you can tell it's special, okay? Without making so many points. But this is first time, right? So we need to write out all the points, okay? So let's start with the asymptote, right? Scales first. So negative 1, negative 2, negative 3, 1, 2, 3. And then we can go up to 4, 2, 3, 4. 1, 2, 3, 4. All right, and then asymptotes. Asymptote we have at negative 2. So let's draw that here. And then at 0. Okay. And then horizontal asymptote was 1, right? Don't forget, horizontal asymptote is at 1. So it'll be up here. Okay. So please plot all the points. Don't draw the lines yet, okay? So plotting the points and raise your hand, okay? Negative 3, 4, and 2/3. So about there. Negative 1.5 is negative 3.6. So about here. Negative 1 is 0. Okay. Negative 0.5 is 3. 1, 2, 3. Okay. And then 0.5 is negative 4.2. 4.2, so about here. 1 is negative 2. And then also plot the intercepts, okay? We have an x-intercept at 4. 1, 2, 3, 4, so that's here. Right? And then we have another at negative 1, which we already have. Okay, looks like very random, right? Please raise your hand if you plot all the points already. So how are we going to draw the curve now? Okay, we have 6 sections, right? With the 3 asymptote, we get 6 sections. For the left side, the far left, okay, top left, that part is easier, okay, because you only have 1 point. So it will just bend like that, right? Gets closer and closer to asymptote. Okay, so that part, no problem. Okay, and then same thing for the top, for the right side, bottom right. Okay, it will be also bending like that, right? And then crosses the x-intercept. Right, gets closer to asymptote. Right, far to the left goes to the asymptote. Right, to the right also gets close to asymptote. Now the problem is in the middle. Okay, if you compare this question with the previous page, okay, the one that also has 2 asymptote lines, 2 vertical ones, right? The graph that we had before, the one on the left is on the top, right? The one on the right is also on the top. Okay, then the middle one will be at the bottom. Okay, now for this one, it's different. You have one side that's on the top, the other side is at the bottom. Then the middle one, because of the table, you can see that it has to go through the asymptote line. Okay, so asymptote line is only for places that's very far, right? It's a guidance for points for the graph for far right or far left. So somewhere in the middle, it's possible for the graph to cross, okay? So the way you will connect the middle one is the bottom part, it will curve like the right side. Right? You see the way it curves is kind of like the right bottom corner, right? And then once it goes past the asymptote, now it will curve like the top left. Okay, so looks similar to a cubic, right? Remember when you draw the cubic, it looks like that. Okay, so the middle part will bend like this. So this will only happen if you have left side and right side at different place, one at the top, one at the bottom. Okay, so if it's the other way around, okay, so let's say if the asymptotes, okay, these blue lines are asymptotes, okay, so if the graph goes like this, then the middle one will bend, right, like this. Okay, so if it's the opposite, right, upside down. Any questions? Okay, so this one very special, right? We have 2 vertical asymptotes, but it could be the question in type 1, or it could be the like this one, right? This one, the middle part can cross the horizontal asymptote. Okay, so after the break, we will do the type 3 and 4. Okay, if you have any question, you can stay during the break and ask me. Okay, so I will take 15 minutes break. So I'll see you guys at 6:40. Okay. Yeah, I'll see you soon.